A hexagonal pyramid, side of base 30 mm and axis 70 mm, rests with its base on HP and an edge of base parallel to VP. A section plane inclined 45 degree to HP and perpendicular to VP passes through the pyramid at a distance of 30 mm below the apex. Draw the front view, sectional top view, true shape of the section and development of the remaining lateral surface of the pyramid. So in this case it is regarding a hexagonal pyramid and it is also involving a sectioning process. So we require a front view, sectional top view, true shape and development of the remaining lateral surface of the pyramid. So as it is a problem involving sectioning process, the very first step is drawing the symbol front view and symbol top view using type B lines. Already I have done it as per the requirement of the question. Here one of the sides, one of the base edges, it is parallel to VP. That means it is parallel to the XY line in the top view. So I have drawn the symbol front view and symbol top view as per the requirement of the question. So after drawing the symbol front view and symbol top view, the very next step is locating the section plane. So it is, we are having a section plane which is inclined 45 degree to HP and perpendicular to VP. So as the section plane is inclined 45 degree to HP and perpendicular to VP, definitely it is to be represented in the front view and it is passing through a point which is 30 mm below the apex. So 30 mm below the apex. So we shall mark the point through which the section plane is passing through the solid. So along the axis we shall take a distance of 30 mm. So through this point let us draw a reference line which is parallel to the XY line. Now let us take an angle of 30 degree with respect to this line and here this point is 30 mm below the apex. The angle of the section plane is 45 degree with respect to the horizontal plane. So we have drawn the section plane. It is inclined at an angle of 45 degree. It is passing through a point 30 mm below the apex. Inside the solid it is a thick line. Outside the solid it is a chain line. The ends are thickened and here I have written it as vertical trace. Now we shall mark the meeting points of the section plane with the various lateral edges of the solid. It is not meeting with any of the base edges. So we shall now mark the meeting points of the section plane with the various lateral edges. So in the front view we are having visible edges as visible lateral edges are PF, PE, PD and PC. So here this is PF, this is PE, this is PD and this is PE. So all these lateral edges are meeting the section plane at some points. Let us mark those points as 1, 2, 3 and 4. On the rear side we are having slanting edges PA and PB. So P dash A dash and P dash B dash, they are not visible in the front view. So there also we will be having a meeting point of the section plane with respect to P dash A dash and P dash B dash which are invisible. We shall mark those invisible points. Here we shall mark it as 4 dash and here we shall mark it as 5 dash. And we shall transfer all these points to the top view one by one. We can transfer it all these points directly. So 1 dash is on PF, so this is PF. 2 is on PE, so this is PE. 3 is on PD, so this is PD. 4 is on P dash C dash, so this is PC. 5 is on PB and 6 is on P dash A dash, so this is PA in the top view. We shall transfer it. Now we shall join 1, 2, 3, 4, 5, 6, 6, 1 using thick lines, and after that we shall hash the inside region. Now we shall draw the remaining regions in the front view and remaining regions in the top view. So in this case, this is the section plane. This regions will be removed, and this portion which is below the section plane will be remaining. So all the base edges and slanting edges which are below the section plane, they have to be drawn with thick lines. So here 1 dash f dash is remaining, 2 dash e dash is remaining, 3 dash d dash is remaining, 4 dash c dash is also remaining, and on the other side we are having 5 dash b dash and 6 dash a dash. Currently we are unable to represent it using dash thick lines because 6 dash a dash and 5 dash b dash, they are overlapped by 3 dash d dash and 2 dash e dash. And we shall draw the remaining regions in the top view also. So here 1 dash f dash is remaining, so this is 1f, 2e is remaining, 2e, 3d is remaining, so 3d, 4 dash c dash, so 4c is remaining, 5b, so 5b is remaining, 6 dash a dash, so 6a is remaining, and the base completely is remaining. We shall draw each of them using thick lines. So this is a front view and this is a sectional top view. This is not the true shape because we are having an inclined section plane here. So if you are observing this solid from the top, that is from this particular position, you will be unable to get a clear idea of this sectioned surface which is inclined here. So what we have to do is we have to straighten this region, that is 1 dash 4 dash. We will be drawing it as a straight line on the right hand side, and then we will be trying to obtain the true shape. So in order to get the true shape, what we have to do is we have to observe this region perpendicular to the section plane. Then only we will be getting a true shape when you are observing the solid. So in order to facilitate that, what we will be doing is we will be just straightening this region 1 dash 4 dash, and we will be drawing it on the right hand side. We shall extend the XY line slightly to the right hand side. We shall measure the distance 1 dash 4 dash. It is approximately equal to 51. So this end it is 4 dash and this end it is 1 dash. Now we shall mark 2 dash 6 dash and 3 dash 5 dash with the help of compass by taking measurements from the front. Now we shall extend projectors from this line to this area and from this 1, 2, 3, 4, 5, 6 to the right hand side. So here this point is point 1. We are extending projectors from this top view 1 and this front view 1 dash. That is how we will be getting 1 here. So likewise you have to find all the other points. Now join 1, 2, 3, 4, 5, 6, 6, 1 using thick lines, and afterwards you have to hatch the inside region using hatching lines. Now we shall draw the development of the remaining regions of this hexagonal pyramid. So already in the front view, P dash C dash will be having its true length. So in order to draw the development, we require the true length of the slanting edge and we require the true length of the base edge. So true length of the base edge is also already available, which is 30, and true length of the slanting edge we shall measure the length of P dash C dash. So P dash C dash will be having true length because PC is a straight line that is parallel to the XY line. Also P dash F dash also will be having true length of the slanting edge because PF is also parallel to the XY line. So we shall measure P dash C dash. So it is approximately equal to 72 or 71, whatever value you are getting, you take it as such. So we will be marking point P here. Now draw a straight line with this 72 mm in the scale vertically downwards using thin lines. Now with 72 mm as a radius in your compass and P as center, draw an arc. Now the base edge length of the pyramid is 30 mm. So take 30 mm in compass and cut 6 arcs along this bigger arc. Now join all these smaller arcs, these meeting points to P using thin lines. Now let us assume that we are unfolding the solid with respect to slanting edge PA. So we shall write here this side as PA and this side is also PA. As we have named the symbol top view in the clockwise manner, simultaneously these points will be B, C, D, E, F and this will be A. We shall write that. Now join AB, BC, CD, DE, EF and FA using thin lines. This is the development of the lateral surface of this pyramid. Now we have to transfer 1 dash, 2 dash, 3 dash, 4 dash, etc. to this development. Then only we will be able to draw the remaining portion after the sectioning process. As we know, all the lines along this development they will be having their true length. So a transfer of true length to true length is only possible here. So 1 dash and 4 dash they are already on true length slanting edges, so we can transfer P1 dash and P4 dash directly, whereas 2, 6, 3, 5 etc. have to be transferred to a true length slanting edge. Then only we will be able to transfer it. Now we shall transfer 2 dash, 6 dash, 3 dash, 5 dash etc. to true length slanting edge, which is P dash C dash. So this point will be 2 double dash, 6 double dash and this point will be 3 double dash, 5 double dash. And we shall transfer each of the points to the development. First we shall take P dash 1 dash. So 1 dash is on PF dash. So this is PF. 2 dash and 6 dash they are on P dash A dash and P dash A dash. So we have transferred it to a true length slanting edge, which is P dash C dash. So both 2 double dash and 6 double dash they are having the same measurement. So with this same measurement we have to cut arcs on PE and PA. So here this is also PA, so totally we have to cut 3 arcs. So this point is 6 and this point is also 6. Now we shall transfer 2. 2 is on P dash E dash. So this is PE. Now we shall transfer 3 double dash and 5 double dash. We shall measure it from the front view. So 3 dash is on P dash D dash. So this is PD, and 5 dash is on P dash B dash. So this is PB. 4 dash is on P dash C dash. We shall measure it. So this is PC. And we shall join 6, 1, 2, 3, 4, 5, 6 using thick lines. So if you notice the front view, all the regions which are above this 1, 2, 3, 4, 5, 6, they are removed after the sectioning process, and this region is remaining. So the regions which are above this line, this portion is removed and this portion is remaining. Now we shall draw the outline for the remaining portion. So what is the outline for the remaining portion? Already 6, 1, 2, 3, 4, 5, 6 it is drawn here. Then it is 6A, AB, BC, CD, DE, EF, FA and 6A again. So we shall draw these lines using type A lines. So in this case, we have taken these measurements to mark 1, 2, 3, 4, 5, 6 from the front view. So just to indicate that we have followed the correct procedure, we'll be marking some 2 or 3 of the dimensions here. In this problem, we have drawn the front view, sectional top view, true shape and development of the remaining portion of the solid. So usually in questions, you will be asked to draw only a combination of front view, sectional top view and true shape, or else it will be front view, top view and development. All these together won't be asked in, usually it won't be asked in questions, only a combination. So here I have done it together in order to save time.